So in this video I'm going to be looking at the second Yagi design that I've been working on, and it's this one here with its multiple elements that fan out along the boom there. I do actually like this design, and this design does have slightly more gain than the previous one that I showed you in the last video. Now, a lot of the methods that I'm going to use to actually construct this little Yagi antenna are the same methods that I actually used for this one here, so I'll put a link in the description so you can have a look back at that one if you haven't seen that video already. So hopefully this one's going to be a little bit shorter than the previous one. So let's get the tools out then, and I'll show you how to make this little unique Yagi antenna for 2.4 gigahertz. So I've got a piece of box tubing, the same that I used in the previous Yagi video. This is brass box tubing, and it's 8mm square, and I've got a length here that's 150mm long. So what I've done then, I've measured in 5mm from the edge of the box tubing here, and I've put my first mark there, and then what I've done, I've measured 30mm from that mark to this one, and I've done the same again round here, and 30mm for this one here. And this mark here is where the back reflector is going to go, and I've measured 60mm from this parasitic element all the way here to the back reflector. Now for the parasitic elements, what I've got here is some copper wire, solid core copper wire. It's 1.5mm in diameter, and I've cut them all off at lengths of 50mm. Now I've cut them all off at the same length because what I'm actually going to do is fix them to the boom itself, and once they're actually fixed in place, I'm then going to come in right at the very end and cut them off to the correct length. It's just much easier doing it that way than trying to measure all these individually. So I've got my bradawl here, and what I'm actually going to do is put 3 indentations on these 3 lines here to help guide my drill bit when I come to drill the holes for the actual parasitic elements. So I'm going to put an indentation quite close up to the side wall of the tubing up here, and a second one down here against the side wall at the bottom, and then I'm going to put a slight indentation just directly in the middle there, and I'm not going to measure those off. I'm just going to guesstimate it and do it by eye using this line to help guide me. So I've finished using the bradawl to put the indentations in where I want to actually drill the holes, and I've done both sides of the boom there. So what I'm going to do now is very carefully drill each one individually out using a 1.5mm drill bit. So I'm going to do this side and then flip it over and then do the opposite side as well. So I've got all the holes drilled on the boom now, and I've just got in there and cleaned them up with some emery paper because I'm going to be inserting the elements through the holes all the way to the other side and actually soldering these in place, these little copper elements. And I'm going to start at the end here and work my way back with this particular Yagi. So I've got the elements through the boom there, and what I've done, I've just lined them up in the center, because remember I'm going to be trimming these off to the correct length at the end when they're actually soldered in place. So I'm going to solder one side at a time, and I'm going to hold it in my vise here while I actually solder them. Now I've got them held in the vise now, and I've also used 2 pieces of scrap wood to actually hold the elements in place. And the reason I do that is because this is a metal vise, and I've found that when I actually clamp it down directly onto the elements, it just acts as a big heat sink. So I have to get a lot more heat in there to actually do the job than I would if I used a couple of blocks of wood as an insulator. Now something else that I've found is just prior to soldering makes the job of actually making this antenna a lot easier if you slightly bend out the elements away from each other. So I've just got my metal ruler and just gently bent the outer elements away from each other, just so I can get in there with a solder and get a nice solder joint around the top of each one of those elements there, because we aren't going to be bending these out at the end, but we're going to be using a protractor and doing it to roughly a 30-degree angle. But for now, if you just prise them apart slightly so you can get in there with a solder. So I'm ready to actually start soldering these in place. Now I'm going to be using the soldering iron and finishing off with a small pen butane torch. Now what I'm going to do is use the soldering iron to flow some solder on this side of the elements. Then I'm going to flip it around in my vise here. It's slightly angled, so I'll flip it in the opposite direction, and then I'll use a soldering iron on this side to get some solder in around there. And then what I'll do, I'll flip it upright and use my little pen blowtorch to get some heat right into the boom and the elements there, and hopefully it should all flow nicely around the top of here and we get some nice straight joints. It's probably the best way that I've found to actually do this, but it's quite difficult to show it on camera, but I'm going to attempt to show you on this one just so you get the idea of what you need to do. So I've got my soldering iron turned quite high, so I'm going to get some solder around this first element here first. Gently let the heat build up in there. And then move on to the second one, flow some solder around that one. And then finally the third one. It's just a matter of being patient with the soldering iron and letting the heat transfer and build up, because there is a lot of metal there. So what I'm going to do now is flip it around in the vise and come in from the other direction. So I'm coming in from the opposite direction and doing the exact same thing again. So I'm going to be using this pen butane torch here. It's not a bad little butane torch. It is a soldering iron as well from Tool Zone, but as a soldering iron it's pretty poor, but it's not bad as a little butane torch. So what I'm going to do then is slowly build up heat in the boom more than the element itself, because the soldering iron did not do a very good job of getting heat into that brass. It's done not a bad job with the copper wire, but I really want a good solder joint with that boom itself. Just turn it around and just get some heat in the other side. You get a much neater job that way. So now what we've actually got, using the pen torch to finish this off, we've now got a good joint between the boom and the elements themselves. So these are in there, they're pretty strong, they're not going to go anywhere. So what I'm going to do now is flip it the opposite way around and do the same with the other side and solder the rest of the parasitic elements in place as well. So now that we've got the three parasitic elements in place, I'm now going to actually make the driven element of this antenna. So you're going to have to get yourself a short pigtail of coax with an SMA connector connected to it. Now this was originally 100mm long, but I've stripped it back and I've made this T shape on the end of the coax here, so I can actually solder on to the driven element, and the coax that's left is around 60mm in length to the start of the SMA connector there. Now to make the body of the driven element itself, I've got some of the copper wire, the same diameter we've been using to make the parasitic elements out of, and this is exactly 126mm long, which is one full wavelength at 2.4 GHz, and I've measured in a quarter wavelength at 31.5mm, and I've put a little black mark here, and I've done the same on the other end and put a little black mark here as well. So I'm going to take my main driven element now, and I'm going to put some bends in where I've put the marks on a quarter wavelength at either end. And what I'm going to do, I'm going to bend it in a semicircle and I'm going to use one of these laptop batteries to actually bend it. It's got this little ridge at the top here, and this is about 18 millimeters in diameter. So I'm about ready to bend the copper wire, and I want to keep that little black mark there in the center of the semicircle. So very carefully I'm going to bend it around the battery, keeping it nice and even and getting a nice circular bend around there. So bending it nice and slow, keeping that point at the top there, so each one of these legs is bent round equally around the battery. So I've got that bend nice and equal with the little black mark there right in the centre of that semicircle. And what you can also do is lay this flat on your bench and get your battery and just give it a little roll so you get that semicircle nice and smooth, the curve all the way around there. And now you just want to do the same on the opposite side. So I've got the driven element bent into the shape that I actually want, and as you can see, they're just not quite touching here at these 2 points, but I'm going to get in there with a very small file just to make that gap a little bit bigger and just to flatten off these edges as well. And that's the size of the gap. Now I've actually got in there and ground the edges down flat, and instead of using a file, what I actually used was a flat cutting wheel on a Dremel, just got it in between there and just ground down both edges. So we've got a very small gap there now, probably about 1.5 millimeters. So I've trimmed the coax back even more just to tidy it up so we can solder it directly onto our driven element here. And I've also got a little bit of heat shrink tubing which I'll pull up over here just to tidy it up a little bit. So I'm going to tin the driven element here and here and then solder that directly onto the copper wire. So I'm going to mount the driven element now onto the boom itself so we can finish off this antenna and attach the back reflectors. Now what I've actually done, I've measured 20 millimeters from the first parasitic elements here back and put a little mark there because that's where the driven element wants to sit. I've already put this heat shrink tubing around this part of the boom just to make sure that I don't short out the driven element to the boom, because you want it completely isolated from the rest of the elements. Now I'm going to mount it onto the boom, but I also want to lift it up slightly from the boom because I want it to sit in the center of those elements nice and evenly. So if I mount it directly to the boom like this, it's going to sit too low at the bottom here. So I've got a small piece of brass tubing here, the little box tubing I've used in previous videos, and this is 4 millimeters on each side. So I'm going to use that to attach to the boom to lift the driven element up slightly, but you can also use a small piece of wood, something like that, about 4 to 5 millimeters. So I just wanted to show you the heat shrink tubing here. Now I'm not using glue to affix that small piece of box tubing down onto the boom here. What I've done, as you can see, I've got some heat shrink tubing, quite long, longer than the piece of box tubing here, and just shrunk that down. It shrinks down at the edges as well to this curve. It just finishes it off quite nicely, so we're not packing epoxy putty in there to block off the edges or anything like that. It's just a lot neater. And when the driven element's in place, I'm going to put that there like so. I'm not going to glue that down either. I'm going to use some more heat shrink tubing to tie it down on the boom itself. And as you can see, I've also put the epoxy putty in place just to tidy it up and make sure these two ends don't come into contact with each other. So that's the main driven element finished and in place. So what I'm going to do now is solder in the elements for the back reflector. Now I'm just going to use the same method as I did with the parasitics, but this time I've got 3 lengths of the copper wire at 90 millimeters long. And again, I'm just going to line them up in the middle, equal on both sides, and I'm going to trim them down to the correct length at the end when I come to trim down the parasitic elements. So next we're going to bend all the elements to the correct angle. Now I've chosen to bend mine at 30 millimeters. I think this actually works out the best, but you can play around with that angle if you want to. So what you're going to need to get is a piece of scrap cardboard. This is about 60-65 millimeters long. The length isn't as important to get accurate. You just want it long enough to actually gauge against your elements. But what I've actually done is put a 30-degree angle on this side, and I've also done it on the opposite direction on the other side. So what you want to do then is take your little cardboard template and basically use this to bend the elements to the correct angle. So I'm lining the base of this one up on that center element. That one just stays in the center all the time, but you can use it to measure off at the correct angle for the other one. So this one needs bending out slightly against that line, and because we've done it on the opposite side on the underneath, you can just flip it around and then line it up again on that center element and bend the other element out to the correct angle. And you can do this method with all the elements themselves. So now that we've bent the elements to the correct angle, what I'm going to do now is start cutting them off to the correct length. Now, instead of actually measuring each one individually with a ruler and cutting it down, I've got some plastic tubing here. You can use plastic straw as well, and what I've done, I've just cut these off to the correct length, so I can use these to put over the top of the elements and come in with my side cutters and cut them to the correct length. So the back reflectors, they want to be 38 millimeters long. The first parasitic here wants to be 17 millimeters long, and then 16 millimeters, and finally 15 millimeters long. It just makes it a lot easier if you make something like this, especially if you want to make more than one of these little Yagi antennas. And because you're not measuring each one individually, you end up with a more accurate length to your actual elements as well. So I've got both Yagis side by side. I've got the new one on the right and the previous design from the previous video on the left. So let's give them both a scan and see how they actually compare. So now that they're both settled down then, there's not much between these two little Yagis. The software simulation and theoretically the Yagi that I've just shown you how to make in this video should have something like a 1.5 dB gain over the Yagi in the previous video, and looking at some of those signal strengths, it does have a little bit more on some of those, but to be quite honest with you, comparing them both side by side, they are both very similar next to each other. And for a final test, I'm going to test it next to the turbo tenor. I do use the turbo tenor as a yardstick to test most of my Yagi designs against, because it is portrayed on the internet as one of the best Yagis you can get for Wi-Fi. And yes, it is rather expensive. It does work well, but I just don't think it's worth the money. So let's give it a test next to the turbo tenor. So I've just let them both settle down a little bit, but hopefully you can clearly see there that as far as the turbo tenor goes, it's definitely more powerful than a turbo tenor. It's picked up more access points, but a few of those are fluctuating between dead and a weak signal. But just the amount of green that's on the access points from my Yagi compared to the turbo tenor, and looking at the relative signal strength between access points that they're actually both picking up, and it's much better than the turbo tenor, so I'm happy with that. So as you just saw in that test, the performance of this little Yagi is really good. I'm really pleased how this design has actually turned out, and yes, it's supposedly to have a slightly more gain than the previous design, but it's hard to really see that in the real world when you're using them side by side. But as far as design goes, I do actually prefer this one. I do like the way it actually looks. So I hope you enjoyed this video and found it interesting, and if you did, please give it a thumbs up. And yes, I have been a little bit busy the last 2 or 3 weeks. I haven't had much time to spend here in the lab. I did actually start shooting this video 3 weeks ago, I think, but I'm actually just finishing it off today, and today is Christmas Eve, so I want to get this video uploaded tonight or tomorrow early morning. And on that note, I hope you all have a very Merry Christmas and a Happy New Year. And a big thank you to all my subscribers and those who watch my videos. I really can't thank you enough. But hopefully over the holidays I've got a few weeks off, so I can get a few more videos out over the coming few weeks. So again, a big thank you to everybody out there who supports me here on YouTube, and hopefully you'll join me on the next one.